So thanks for being here. We'd like to talk to you about the System Ready framework that we wrote and are currently using. And we'll be joined by Christian later with a cool demo. So who are we? Christian is, we're both working for Adobe Switzerland and involved in oh, that's an old picture that I somehow, weird. We both work for Adobe Switzerland and are involved in some Apache projects. Christian is very much involved with OSGi and a contributor to different projects, an ASF member, and writing tutorials and blogging about OSGi. And I'm involved with Sling and Felix. And you can reach us out on Twitter, and we have some details there about our GitHub repositories and all that. So the motivation for writing this thing was basically something that we needed to know, which is when is our application built on top of OSGi ready? And why did we want to know this? We had two main practical motivations, which are, first of all, we have a lot of automation in AEM. With end-to-end and integration tests, and we always had this issue about where is it, if we did a deployment on the spot, where can we start hitting the instance and so that our tests make sense as fast as possible and as reliable as possible, right? And probably more importantly, another motivation is when is our application ready to receive traffic? Because if we're moving into deployments that have some sort of zero downtime strategy, like rolling updates and using Kubernetes with replica sets and all that, we need to make sure that that system works and traffic is only sent to that when we want it to be, when we say our application is ready. So the question is, what would ready actually mean in a generic context? So OSGi, an application on OSGi is very dynamic. You can register and unregister services all the time. You can do that at runtime. So there is no generic definition as far as I know. I don't know if that's, I heard at some point, some people say that that's the holy grail of finding out when, for readiness in OSGi, is there a formal way to do that? And I don't think there is yet, at least, and we took the pragmatic approach. So what would that mean for us? Is first of all, some particular set of services that we know should be up are up. That's a check that we wanted. In AEM, we also have the OAK initial indexing for a deployment. So if you want the search functionality to work in AEM after a first initial startup, you need to make sure that the initial indexing of the repository is done. So that's another criterion, right? Or you can have a different setup where some critical task that runs in the beginning once one-off, like migrating users from an LDAP database, is done. And you might want that for your application or deployment. So we quickly reached this conclusion in a way that for complex applications built on top of OSGi, we need application-specific checks. And not only that, but we might need deployment-specific checks for the same application based on the context that we deploy our application. For example, you might not use LDAP, you don't care about that. You might use a different system, you might want to check for that, right? So that's the motivation. And then before we jump into how it works, we can talk about what it can do right now and where you can use it. And some use cases are Kubernetes. It provides nice HTTP endpoints for readiness and liveness checks that Kubernetes can use with its, what are they called? Liveness and readiness, I guess, configuration. You can also use it in PAX-exam, for example, where you can programmatically wait for your framework to install everything that you need and then run the tests. We also have, that's kind of a teaser, we probably don't have time to go into that, but right now it also has the root cause analysis for the services, like why, if a service didn't go up, it can tell you the root cause of it in the test, and that can be very useful, and that's something that Christian brilliantly developed, I think. Another thing we use it in is end-to-end automated tests, is what we were talking about, which is when are you ready to make a deployment, a test deployment, when are you ready to start testing against that over HTTP? And make sure that you're not getting weird false positives. We also can use it on standalone deployments. So on-prem AEM, for example, you can use it for the initial startup, whatever automation tool you have for that, for the jar or Sling. You can use it for the initial startup to make sure that it's done and signal that in a way or have that in your application. Or you have the runtime readiness. At some point, it might turn that it's not, your application is not ready again. And that can tell you something and can use it in your deployment tools. Not to be confused with Sling health checks and stuff like that. We can talk about why that's different and why we didn't use that. We can touch on that a bit. So, what is it? It's a very small bundle. It's a 50K OSGi bundle that lives in Apache Felix. It's framework agnostic, so you can use whatever framework you want. It has very little dependencies, and it's quite small. Even though it's small, it has some ready checks built in that you can use and configure to your liking. One of them is the framework started check, which basically checks that, basically can do two things. It's quite flexible. It can check that the OSGi framework is started, like what happens on the server side when you get the started event, or you can check that a certain start level has been reached, which is very useful for AEM, where we have this kind of step-by-step startup. We also have the services check, which reports through if reports ready when the services when a particular list of services is present, based on a configuration, or the dynamic DS components. A certain list is present, and all these we have an interface, and you can extend it by adding your own checks quite easily, and Christian will show that in a bit. What we also have, and that's kind of the bringing it all together, is obviously an aggregating system where we report green, yellow, or red. Green is obviously ready. Yellow is not ready yet, but is going to be ready. And red is something went wrong and is not going to get green from that, basically. So that aggregator just takes the worst report from all of them, right? And we have some built-in servlets in there for readiness and liveness. And they report 200 for green or 503 otherwise. So you can use that in your automation again. And yeah, we also have the root cause analysis for missing components that you can check on the server side, I think, in your own service, and make use of that. Just kind of a teaser of how the aggregator looks like. Of course, you can call it on the back end. It's a service, but the HTTP servlet reports something like this. This is a 503 code, and it's reporting the system status yellow because we have two checks. One that is the framework start ready check, which is they're bundled. That reports green because the framework has reached the configured start level, which is 30. So that's green. But then we have another custom check that means for our application or our deployment, that's not enough. We need to do something after the framework has started, and that particular custom check still has 2 out of 5 things to do, and is reporting yellow. So the overall status is yellow. So you can use that 503 code to, Kubernetes, for example, can use that to see that it's not ready yet, for our own deployment. And then I'm gonna let Christian show you the architecture and then go into a demo, and then I'll probably come back with a short demo.
Okay. So, hi. I just set up my system. So we can start. Good. So I would like to show how the system-ready framework is structured. So the core, of course, are the system-ready checks that we see here. In our case, this is one liveness check and two readiness checks marked by these symbols. Two are green, one is yellow. So each check has an individual status, and the system-ready monitor is basically polling over these checks, and each check is asked, what is your status? And it would return these ones here. So the system-ready monitor offers an OSGi service, so you can access it on your own. It also offers a marker service when the system is ready, in case you want to depend on that for your own stuff. But of course, the main reason for having this is to feed these servlets. And we have a ready servlet and then a live servlet, which matches exactly what, for example, Kubernetes wants to have. So it's very easy to match that. You can have both on each of a path, like by default system ready or system alive. And when you call them from the outside, you get the HTTP status and also some more details, like shown in the previous slide. So in that case, readiness would show yellow, because all three checks are considered applicable for readiness. And for aliveness, we would have just one check, which would report green. So one thing to explain, readiness in the sense of Kubernetes would mean if a system is ready, it is part of the load balancer, so it can receive traffic. And if a system is not alive, it would be restarted. So the whole system would be deleted and pulled up again as a new pod. So how can you use it in practice? If you have Sling, you can just add it as an additional bundle. It is not yet in the Launchpad, but probably it will be soon. And we already have it out of the box in the upcoming AEM 6.5. We already also test inside the cloud, so this looks all pretty good. And you can also use it in your integration test just by adding the additional bundle and the few requirements it has. And the nice thing is, this is also why we put it to Felix, not to the Sling Apache project, because this framework is very decoupled from anything Sling. It's just based on very few OSGi APIs, so you can use it in any OSGi deployment you have, and it's really easy to apply. So let's blow up some Kubernetes pods. Let's see how affecting the readiness or aliveness would be treated by Kubernetes. So the first thing I show is on Kubernetes, then Andrei will take over and look into AEM deployment. So, but first I would like to give you a glimpse of how it looks on the Felix side. So it's not yet inside the main HTTP side, but it's on GitHub. And you see, just enter on the top level Felix, and then go one level down to system ready, and there you find some kind of integrated, integrated documentation. So this is a bit around the project, how to build, how to report issues and whatever. And the core part is the reference documentation, which is done in the same way. And this should help you enough to get it running in Karaf or in any other OSGi framework. So you see how to use the checks, how to use configuration admin to configure the checks. And the available checks are the framework start check, the services check, which you just give a list of service interfaces to check. The component check, this is for DS components that do not provide a service, so you can even check these. And how to do custom checks and how it all works, and in the end, the servlets and how to configure them and what to expect from them. So this should help you get started pretty well. And also an example here for the root cause analysis. We also have a small command for the Felix Gogo shell. So if you have a shell in your system, you can ask it for the root cause for why a certain DS component did not start, and you get it down to the through the references of the component and show what is missing. For example, in that example, there's a missing config. So now let's look into Eclipse. So this is our example I would like to show. We have one bundle here, our example Kubernetes. It is implementing 2 checks, one alive check. So the main thing here is basically this system ready check. This is from the system ready framework itself. And additionally, we have a servlet that we implement so we can trigger it. So basically, this is what you do for a check. You are called on the getStatus method, and you return a status with the name of your check, the type of your check, and a state, which is either green, yellow, red, and an explanation, especially for the case when it's not ready, why it's not ready. So you can do quite a bit of detail here. Basically, this check allows you to trigger from the outside that it's going from green to red. And for a live check, this should basically reboot our pod. And for the readiness check, it's similar. By default, it's reporting green. And you can switch it off for a certain time, here 60 seconds, which means your pod should be taken out of the load balancer for 60 seconds and then brought back in again. So basically, this is all that is inside of our little bundle. The only other thing is a small HTTP page as an entry page where you can trigger the stuff. Not much interesting here inside that. One thing that is quite interesting is that we already used the OSGi R7 things to make your bundle very self-descriptive. So it automatically creates requirements from some annotations to make sure it can be resolved with everything it needs. So it's very easy to deploy. For deployment, I used BND tools, where you simply provide a POM with the bundles. It also includes transitive dependencies, so it's quite a few, but I even have more in there than I need. And basically, it creates an OBR index on the fly when doing Maven. It resolves our application to a list of bundles to run, and it exports it to a runnable jar that can be very nicely run in Docker and Kubernetes. So there's also this view from BND tools where we see on the left side the repository. This is created basically from the POM dependencies. Then you have a list of requirements. Here you see that it's really easy. I just provide the repository and my own bundle as the only requirement. And the bundle already contains all the requirements to make a good resolve. So when I do a resolve, I get the list of all bundles it needs. And this is a list that works out of the box. So basically, when you build it, this is created as an app jar. In our case, just 5 megabytes. So this is really light to install. It includes everything, OSGi and all your bundles, everything you need. And we use this in a Docker file to boot that up inside Docker. Yes, I don't want. So this Docker file is then used in a YAML file for Kubernetes. So we just tell it basically to use our Docker image, and we add the readiness probe and the liveness probe. And this is all you need to tell Kubernetes to use the system ready framework. And basically, this is all necessary for get it running. And of course, you need a service basically to define the load balancer in front and how to access it. So this is all standard Kubernetes stuff. So now, let's install that. So when we look into the, better type it, kube control get pods, we see nothing there. And we do an apply -f. This is basically apply the YAML file. So it installs our pod. And the service is already present because I cheated there a bit, because creating a service and load balancer takes quite a while. So now it starts to get installed. And I can also use this one. Basically, this is the -w means poll regularly, so every change is reflected here. And we can look at this to see what happens. So it's already running, and it's ready. It was not restarted until now. So we can now go to the browser and go to the, where is it? I need the IP, kube control, get services. And here we have the external IP, so you could even also access this. This is open in the cloud, but please don't play around with it and do funny situations. So we see it's up since 60 seconds, and we also see the ID of the pod. So now, sorry? Yes, could have it a bit larger. Zoom in, zoom in. Is that good? Basically, we can just see there is a ready state green, there is a live state green, all fine. But now, of course, we want to simulate what happens if it's not green. So we can report not ready for 60 seconds. So the ready state is now red. But of course, it takes a while for Kubernetes to capture that. We also have the Kubernetes Dashboard, which is green by default. Oh, it's gone again, like it likes to. So anyway, we see here still our running command that it likes to switch. So we have the dashboard now. Come on. So we see it's not ready at the moment. We can now, oops. We also see that here, it's not ready. And if I'm fast enough, I can also try here, and it should not respond anymore. So we see it's not loading. It's hanging kind of. It would come back after the 60 seconds and be there again. Let's see, this is here. So we see already it's coming back, but it takes a bit longer for the HTTP on the browser to also report. It's already back. So we see it's responding again, and it's still up. So it did not stop. It was just taken out of the load balancer while it was not ready. Now it's ready again, and we can access it again. Of course, if you have a replica set of more than one instance, you will not have a completely unavailable website, but just taken your not ready pods out of the load balancer and still be able to serve traffic with all the remaining active pods. So you can use it, for example, for zero downtime deployments where you have your new deployment which comes up, but it's not yet ready. And as soon as it is ready, it is taken into the load balancer. Or also when you start the upgrade, you take it out of the readiness. It's taken out of the load balancer. You can do stuff on it. And once it's back, you can report readiness again. So this is the ready or not ready case. And now we have the not alive case. It's similar. We just show red on this alive state, which will also make the service unavailable after some time. Let's maybe first look in the here. So after some time, we should see that it's not responding anymore. Yeah, actually, I'm not sure if you can really see it, but after it comes back, we will see there is a restart and it's up again. But now now it's not serving traffic anymore, but now it's not just taken out of the load balancer, but the whole pod is taken down by Kubernetes because it's not returning I'm alive, it's running I have a problem. And Kubernetes now restarted it, and we see in the uptime 21 seconds that it is freshly started. And we also can see this here, that I just missed the last part. So we see it's ready again, and it has restarted. So these are the two cases you can cover with Kubernetes. One is taking your system out of the load balancer, and the second is taking your system completely down and bringing it up again in case you reported it's not healthy anymore. So I think that was all for the Kubernetes part. And I give back to Andrei to continue with the AEM demo.
All right. Nice. So I think we still have a few minutes.
This is not correct. I started too late.
Yeah, I know.
So we don't have much time.
No, we don't. I'll be quick. It'll be 1 minute. So I just wanted to show you how we can use it for AEM right now. I just wrote a demo check, very, very similar to what we did with the Kubernetes one. Okay. And it's, yeah, just the same thing. So it's a demo check. It implements a system ready check. That's all it does. And it has a name, and it's just, that should probably be an OSGi configuration, but it's just waiting for 50 seconds. So it's not doing much. And until the 50 seconds has passed, since it's activated, it reports yellow, and then it reports green. That's it with this. And then how can you use it in AEM? You just put it in a, basically, the install folder somewhere, right? And you put it here. And we also have a configuration here for the, at least I do on this deployment, for an already present check, which is the framework start check. And I'm saying, basically, okay. It's just setting the property to the start level to 30, and that's it. So when it reaches 30, this particular check will say it's ready, the other one needs 50 seconds. So I'm just gonna quickly, basically I have a script here. First of all, let's go over it. It's not much. It's just a poller that does a curl on the system ready, well, on whatever endpoint you give it, that's a function, and then it reports when the return code is 200 or it reached the maximum number of accounts, it exits. So it waits for 200, right, on that URL. And then what I'm doing is just taking the jar file that I have locally, starting it, forking it, disowning it, and then I am doing a poll on localhost, the port, and the system-ready HTTP endpoint. And then I have a printf that starts, you can start your automation now. So this simulates running some tests after the system is ready. Okay, I think I closed something. Okay, and this will take literally a minute, so bear with me. It's ugly at this point because there's no web server yet, so it's just not returning a code until we get the Jetty running. And this, something go wrong? I hope not. Started to doubt it. Now we get a 404. And there's another, now the path is just not found, the servlet is not registered, and then now we have a filter, which we probably need to disable. because this is supposed to give you the status, but there's the Sling filter on top that just says startup in progress. But towards the end, so in a few seconds, after the filter is unloaded, disabled, then we will have the checks right now. So it's saying the framework is not started. The start level is 20. Now it's 30. But you can still see that there are 42 seconds left on the other check. So we have 2 checks here. The system status is yellow. The framework start ready check reports true, green, because it reached start level 30, but our custom check is still reports that, wait, our application is not ready yet. And it's still reporting 503, so our poll function waits, tries that again from every couple of seconds. Does it?
Yeah,
it does.
It does.
50 seconds was too much. So, yeah. I don't know any joke that I can quickly say in 7 seconds, so this is dead air time, so yeah. But now you get the green status because both checks report green. You get the system status green, so our poller just returns to 100, and then we have the message that you can start your test now because everything is absolutely ready. So that was just a bundle, the jar that you can publish and install wherever you want, and some configuration, and you can quickly ramp up your automation like that as the person owning your deployment. So that's mostly it. Those are the resources. You can find the demo on the bottom, and you can find the system-ready code on Apache Felix.
And inside the demo, you see all the instructions to do this on your own. So you can upload the Docker image to your own registry and use your own Kubernetes. So what I used was inside Azure. Just use the standard Kubernetes service they provide, install it with defaults, and you can start deploying that. It's pretty easy.
Do we still have time for a quick question, or?
I guess.
Probably we take them into the lunch break.
Okay.
So
that's fine.
I think, I don't know, if you haven't taken your photos, you will be certainly over there in the back. So whenever there are questions, you probably find both of them in the back for any questions appearing. Well, thank you very much, Christian.
Thank you all.